We just saw how a single tree works. What computers can do really good is find that threshold value. We go back. Should the age be 25? Should it be 18 or any other value? That's something where the computer can actually optimize. The more tricky challenge is, should that be age here or should it be fair? Should I switch that or should it be completely something very different from that, another variable? And to tackle that second challenge, what the computer is going to do in our model is it's actually going to build a very large number of these trees and randomly switch out some of the variables. Once it has built all these trees, they all get estimated. Everyone produces an estimate. So maybe the first tree predicts, oh, I think the passenger should be dead. The second tree predicts, no, I think the passenger is actually likely to have survived. And the third tree also agrees, yes, alive. So then we just take an average over all the single decision trees prediction and their voting. Same as in the parliament, everyone goes down, they're voting, and whoever has the majority wins. So in our case, we have 4 trees that vote that their prediction is the passenger is alive, and 2 trees that vote, I think it's quite likely the passenger is not alive anymore. So obviously alive has won the vote, and the overall prediction of this model is now the customer should be alive right now. Beyond just figuring out the problem of where the different boxes should be sitting, this approach actually adds a great amount of robustness. Even if you had the best ever single tree and everything is optimally placed and all the values are optimal, even that single tree would not be as good as that forest of trees, because the averaging of the trees really gives it a lot more robustness, makes it scale much better, especially in reality when we move from a controlled, almost like a laboratory setting, to hitting reality with real customers in real time and data that might not be as tidy as we assumed. You must have that robustness. So this is great. If you now think this sounds like it's going to be really complicated to build that, then yes, normally you would be right. However, because we have our libraries, it's really easy. So look at this. It's just 2 lines of code. Just 2 lines. Obviously, we are importing a lot from the libraries here. And if you're really lazy, you can just say, okay, import SKlearn, just a complete thing. Right? I'm doing every single one because that's, for the deployment, is a good practice to import as little as possible. But if you want, you can also just say, okay, import the whole SKlearn library. So SKlearn obviously has that model inside, the random forest. And if you just Google scikit-learn or sklearn, however you want to spell it, random forest, you're most likely to arrive at this documentation page. And what's going to tell you is, okay, so sklearn, ensemble, random forest classifier, these are all the different variables I can put inside here. So for example, n estimators is the number of trees. Right here we can see that in the documentation of the parameters down here. And then the best thing about this documentation is you scroll down a bit more, and this is typically the thing I take, is just examples. Copy the code, play with it, and this is beautiful. It even tells you how your X and Y should look like, because they create artificial versions of it here, so you know what shape that X should be like. And if you want to check that, you can also use x.shape and then bracket open close, and it will tell you the shape of that, the dimension of the object. It will show you, okay, this is how you can initiate a basic random forest, and that's how you fit it to your X and Y So these are the 2 lines I had, and of course the import statement as well. And then it also shows you this is how you predict with that. So this example section is super useful and is always great for all the models. All the documentations for SKlearn are really of a very high quality. If you want to know even more, they even have the research papers here. This is, by the way, is one of the most famous research papers of all time. And it also tells you all the different methods that you can use on that on that tree, right, on the random forest model in this case. So for example, here we already saw there is a method fit that we can use, and here you can see, okay, that method is just building the tree. So I can go down here to the documentation. So give it a go. All the models that are in SKlearn, they're all documented on the website and they all follow that same amazing format.